Hello, welcome to Lesson 3 of Practical Geography or Map Work. Objectives of the lesson. By the end of the lesson, learners will be able to 1. Differentiate between a conical hill and a knoll represented by contour lines. 2. Identify a plateau represented by contour lines. 3. Identify a dissected plateau represented by contour lines. Difference between a conical hill and a knoll. A conical hill, also known as a cone or a conical mountain, is a landform, which has a cone or a funnel shape. It is usually isolated and rises above other surrounding foothills. It has steep sloping sides with a pointed top. It usually ranges from 100 meters to 300 meters above sea level. It has a circular base and it is usually a volcanic mountain, whilst a knoll or hillock is generally smaller than conical hills. It has gentle sloping sides. It is usually isolated and rises above other surrounding foothills. This contour is representing a conical hill, and this contour is representing a knoll. A conical hill is a small, isolated, steep sloping mountain. It is steep sloping because, as you can see, the contour lines are closer to each other or to themselves. It is a small hill or mountain because it ranges from 100 to just 300 meters. Now, a knoll is gentle sloping because, as you can see, the contour lines are not closer to themselves, but they are far apart. It is also a small hill or mountain because it ranges from just 100 to 200 meters. And the two are all mountains because the calibration is from the lowest to the highest. So from 100 to 250 and then to 300. And the calibration of this contour, which is the knoll, is also from the lowest to the highest. That is from 100 to 200. The two are all small hills or mountains, but the conical hill is usually higher than the knoll. The conical hill and the knoll are usually isolated because usually they are the only standing mountains in their environment. So you usually see them being isolated and standing, or the highest land in their environment. So as we move further, there are pictures to indicate this. Let us apply cross-section on the conical hill to prove its characteristics. You draw your horizontal line to cut across all the contours like this, and then you draw your vertical axis at the left side, and then another vertical axis at the right side like this. Then after that, you mark the vertical axis here according to the calibrations of the contour. So 100 is here, you have 100, then 150, you have 150. Then you do the same at the left side. Very good. The last is 300, so you trace the 100 contour. So this contour is 100. So the whole of this is 100. So you trace it to 100. The next contour is 150. So you trace it to 150. Then the next contour is 200. Go to 200. Then I think the 250 has been jumped, but it will come back. The tracing will come back. So 300 to 300. You trace it to 300. And then you can see the thin line. The line is very thin, but please let's consider it to 250. Very good. You are done at the left side. Then you move to the right side again. 300. You trace it to 300. Then this contour is 250. You trace it to 250. So as you can see, the lines that you have traced are closer to themselves, indicating that at the end it is going to prove a steep-sided mountain. So you can see we are on 200 and 150. You trace it to 150. Very good. Then the last one is 100. You trace it to 100. A small hill or a mountain with steep side. So this is a knoll. So these are the steep sides. Now, let us use cross-section to prove that this contour is a knoll. So as you can see, the horizontal line has been drawn to cut across all the contours. Then the vertical line at the left side, another vertical line at the right side. Then you calibrate it. So if this were to be a graph book, you would have given it a scale. So for example, 2 centimeters is representing 200 meters. And so you do it according to the calibration of the contour. So now you have all the calibrations here. Then what contour is this? This is 100. So you trace it to 100. Then the next contour is 150. You trace it to 150. The next contour is 200. You trace it to 200. Now you are done at the left side. So you move to the right side. What contour is this? It's the same 200. So you trace it to 200. Then this one, 150. You trace it gently to 150. Then the last contour is 100. Then you trace it to 100. Very good. Then after that, you trace your curve at the end of the line. Very good. To give you a knoll. So as you can see, this is a knoll and it is gentle sloping. The two are all small mountains, but the conical hill is usually higher than the knoll. This is a picture of a conical hill and a knoll. So as you can see, this is a conical hill, so that it is having steep sloping sides. And this is a knoll, it is having a gentle sloping sides. And the conical hills are always taller, or they have height than the knoll. And then we also said that they are usually isolated mountains. So as you can see, both are isolated, and usually they are the only mountains in their surroundings. So you can see clearly in the picture. So these two pictures are knoll, and this is a conical hill. A plateau. A plateau is a table-like mountain. It means that it is a mountain that looks like a table. Why does it look like a table? It looks like a table because it has steep sides with a flat top. So as you can see, this is how plateau is being represented using contour lines. So as you can see, this side is going to be the steep side because the contour lines are closer. Over here too, you have steep sides because the contour lines are closer here. And the space here, you can see that there is no contour. So the space here is going to give you the flat top. So at the end, we should get a pattern that is looking like this. Let us use cross-section to indicate the characteristics or the features of a plateau. You draw your horizontal line to cut across all the contours. Then vertical line or axis like this. Then another vertical line at the right side like this. After that, you calibrate it according to the calibrations of the contour. So the highest is 400, so 100, 200, 300, 400. So you end at 400. 200, 200, 300, 400. You end at 400. Then you trace the contours exactly on the horizontal line, not any other place, but the horizontal line to the marking. Very good. So the 100 contour has been traced. Then you move to 200. Think the 200 line is thin, but that is it over there. Then the next contour is 300. Okay, you trace it. It looks like this tracing is backward, but all that matters is that you trace it to make sure that it hits where you have marked the 400. Again, we come to the right side. So what contour is this? This is contour 400. So you end at 400. Then you move to the next contour, 200. Sorry, the next contour, 300. Then you end at 300. The next contour, 200. You end at 200. And the last contour is 100. You end at 100. So as you can see, the lines you have traced are closer, telling you that you are going to get a steep side pattern. So you trace your pattern. So there is no contour here. So this is going to give you the flat top. So you trace it, you end here, and then you come down. Very good. So this is a plateau. As you can see, the pattern has assumed a feature with steep sides and a flat top. So these are the two steep sides, and this is the flat top. This is a plateau. You can see it clearly over here. This is a picture of a plateau. A dissected plateau. A dissected plateau is formed when a plateau has been deformed as a result of erosion. Yes, originally this was a plateau, but this plateau has been subjected to erosional activities. So as you can see, the feature of the plateau has changed, or you can say that the plateau has been deformed. On some topographical maps, they will trace a curve to indicate rivers. In other words, what they are trying to say is that so many rivers have taken their source from that particular plateau. As a result of this, river erosion has taken place at the sides of the plateau. So over here, they will trace a curve to indicate river erosion. Over here, they will trace a curve to indicate river erosion. Here too the same, here too the same, here too the same. I do not indicate river erosion because a plateau is not deformed by only river activities or fluvial action. A plateau can be deformed by wind erosion. A plateau can be deformed by frost action. In arid and semi-arid areas, there is what we call sand-laden winds. These are winds that are carrying erosive materials or abrasive tools. So, when this sand-laden wind comes into contact with a plateau, it deforms the plateau. So you see wind erosion deforming the plateau. So a plateau can also be deformed by wind in arid and semi-arid areas, or in desert and semi-desert areas. Now, a plateau can also be deformed in the temperate zones, that is by frost action. So, in this case, if there are cracks in the plateau and it rains, the water then fills the cracks in the plateau. So when the temperature reduces, this water in the plateaus become frozen. Now the moment freezing takes place, it expands the cracks. So continuous expansions of the cracks as a result of reduction in temperature will cause parts of the plateau to be broken away. So the plateau is going to be deformed. So this is a dissected plateau. As you can see clearly in the pictures here, this is a plateau that has been deformed. So it could be as a result of rivers that have taken their source from this plateau. As you can see over here too, this is a deformed plateau. So it could be that over here there is a river, or it is wind erosion or frost action that has caused the plateau to be deformed. Let's use cross-section to prove a dissected plateau. I think by now viewers should be able to get the concept behind section is. So you draw your horizontal line to cut across all the contours. After that, you draw the vertical line like this and another vertical line here. Then you mark them according to the calibrations of the contour. So what is the highest contour here is 400. So you end at the highest contour. The same way to over here, you end at the highest contour. So you trace all the contours according to the marking. So this is 100, you trace it to 100. 200, you trace it to 200. 300, you trace it to 300. 400, you trace it to 400. Very good. Now you are done at the left side. Then you move to the right side. This is the last contour, which is 400. So you end at 400. You move to 300. Very good. This is 200. End at 200. And this is 100. You end at 100. Then you trace a curve at the end of the marking. So yes, your flat top. Very good. So this is your flat top. So you can see that, yes, these are the steep sides, this side and this side, but you can see that the sides have been deformed. So the side has been deformed here, it has been deformed here, 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 and there. So this is a dissected plateau. As you can see over here, this is how it looks. Thank you very much. So you visit Educare and Kids for more videos on geography.